While we're looking at our grants page, we also can look at the memory map for the 6502 and 6809 processors. They both have a very similar memory map. The basic in ROM goes at the top of the memory map, and there's other spots that are, some small range of spots that are used inside, unused inside the ROM that are used for I/O. In this case, the two DUARTs or the UARTs can make a dual UART, basically two UARTs. There's a spare range here we'll keep in mind for I/O that we might want to add ourselves. And then at FFD8 through FFDF, there's an SD card. So basically between FFD3, or starting at FFD4 through FFD7, there are spare spots for I/O. That says to me we could have 4 input and 4 output 8-bit registers in that space. Maybe we should poke around with that and see what we can find out. Another thing to note here is that we're doing something that Grant's particular implementation didn't do, because he was using an EP2 FPGA. We're using the EP4 and it has more internal RAM. So we couldn't, with the EP2, get past the 4K internal RAM, but we've got 16K of internal RAM on this FPGA card. So we're getting a pretty decent amount of RAM out of it without having any external chips at all. And we haven't even figured out yet how to tap into the SDRAM, although we got some good tips from one of our YouTube followers, and he had some good ideas. He's done an implementation of FPGA code for the SDRAM that makes it look like it's a big SRAM, and I think we'll play around with that at some later date and see what we can do. Hopefully get up to this larger 56K of external SRAM space. That would be a nice thing to be able to do. So if we wanted to add an additional I/O register or two to the memory map, we've already seen that there's a spare space here with 4 address locations that could be used, but let's see what other changes would have to be done to the code to support I/O. Grant's template has a section where the I/O devices go, so that's probably where we would place any I/O. The CPU definitions themselves really wouldn't change, because the connection out to an output port would be through the CPU data out, and to data in, the DI pins for CPU data in from the 6502 block. Similarly for the 6809, there's address lines, and we would need to decode down to the single address location to do the correct chip selects, but the read-write strobes, in this case the active low write strobe, would stay the same. So no real changes in the processor side. Note, if we're messing around with the Z80 version, that the Z80 has separate addressing for I/O peripherals, so that would be done with I/O strobes, and it's easier, I guess, in a sense, because it doesn't take away from the memory space for the program. One of the things we'd obviously need to do is to create the chip selects, and Grant has chip selects for the basic ROM, the 2 serial interfaces, and the SD card, and so it would have to be some fully decoded address that would be at FFD4 through FFD7 to fit between these two locations. To read a register, all of the different interfaces are all done, and not through a multiplexer, but maybe an implied multiplexer here. The CPU data interface gets turned on to the interfaces, and these are in a particular order because of the ROM and interfaces being in the same space. The way that you pick the particular thing to read is in the priority order here. So if the interface is selected, then it uses the interface out one data out. If interface 2 is selected, then it uses interface 2 out. SD card similarly, and then the ROM after that. So all 3 of those have to be before that. So our data from any register or anything we build into this card would have to fit in the same one of these locations, probably right here before the basic ROM data, to not conflict with the ROM itself. So we've already determined the card is I/O limited in terms of the pins here. They're all currently used by either the VGA digital or by the PS2 digital lines, and that doesn't leave us any pins over here for I/O, but we have 4 LEDs across the top that we could connect with. And we have 4 switches across the bottom, so we could, in theory, make these 4 switches inputs and make the 4 LEDs outputs and memory map them, and then write a little program in BASIC to peak the switches and to poke the LEDs. That's probably a good place to start. Let's go there. I've already written a little piece of VHDL code that implements an 8-bit output latch. It is pretty simple. It has 8 bits of data going in. In this case, it's actually defined in a generic sense with whatever is passed to it for size. So the function calling it would tell it that it needs to be 8 bits. And it takes a clock, so it's synchronous. It has a load signal, which would be our chip select, and it has a clear, which would be the card's reset. And as a result, it produces a latch out, and we could pick off 4 of those 8 bits and send those to the LEDs. The behavioral or the architectural model here is that there's a temporary, those bits are temporarily stored, the QTemp bits. If it's clear, then those values all get set to 0. If there's a clock, rising edge, then if load is present, then what is on the input, the data in bits, get stored across to the temp out, and at the same time the latch out takes those temp bits, and those temp bits get sent out up here out of the module. So this module should be an easy one to insert, and we can just find a spot to decode it, and we should just take a poke and we should be able to make the lights go. Let's give it a shot. I'm going to try to do this live. Hopefully it'll work out okay. I'm only so good with this quartz tool. I go to Files and then right click on Files and Add, and I want to go and select that latch that we just created, and that's stored here inside of Components and under I/O. Am I in the right one? I think I'm in the right one. Maybe I didn't put it in the right one. Let me go wander around and see. Oh, it looks like I put it inside the UK101 or Superboard 2 version. Let me move it over to where we're at with this other piece. Copy. And let's put it down here inside of the 6809 components. Paste it there. And it should be there now. So if we go up here again, yeah, it just appeared. I should have just clicked it. We go back up here to Components, and we go to I/O. We can select it, and I believe we have to hit Add to make it add to the list. And I saw something get added, so I'm sure it's in here somewhere. Yep, right there at the very top. Alright, we've now got an I/O latch, so we now need to call it. So we'll go up to the top of the microcomputer code and see what we have to do here. We don't have to do anything to the microcomputer I/O pins yet, but we will, well, we actually do. We'll have to make LEDs, so let's go ahead and add those LEDs while we're here. And I don't remember for sure what they're called, but we'll just call them LED 1 through LED 4. And make that 2, 3, and 4. So now we have 4 LEDs going out of the card. We probably will have to do something in here, but maybe not. We don't have to do anything with the CPU side, or the ROM, or the RAM. But we want to throw that I/O down in here, so we want to call that something like, it really doesn't matter, but let's call it IO4, IO3. And it's an entity, and it's work dot, I believe it's called, outlatch. We'll grab that and put it, missed the K, here, and it'll say port map. And we have to map the items that are inside of the list here. So this is the list. And there's no better way to do this that I know of. we will have to map those. Let's make that tabbed in like the one above it is. And put those in there. So we don't need the rest of the line, unlike the other ones. And we'll get rid of this. And we'll get rid of that. Did I miss something? Okay, that's good. And back, and back, and back. And so those need the assignment, I think that's called. So they all get assigned to something. And the last one doesn't get anything. So for commas. So for data in, we want to do the same thing the data is on the other one, which is look it up to the data out of the CPU. I think it gets a comma at the end. And the clock will just do the same thing as the clock is up here for the other port. It should be quite similar. The chip select, we will use, make something called N for active low underscore IOCS. How's that sound? For clear, we'll do the same thing that the reset does up here, which is an active low reset. There, I think that's right. Let's see what it says over here. Over here it says if clear is 0, then set it to 0. So that will be active low, which is what we want. And then the latch out we want to have going to different bits. So we've got to figure out how to do that. But let's say latch bits just for now. And it doesn't take a comma on the last one. So I think we've got that right. So let's go ahead and close that entity, and we should be hooked up to the entity. The only thing we need to do is to take this latch bits part, and I think we'll put that up here in signals. I'm not that great at this, so if I'm not doing it right, somebody can feel free to tell me. And it's a standard logic vector sort of a deal, kind of like this one is right here. So we'll steal that and move it down here. So that gives us the latched bits, and down inside of here we'll need to do something to take some of those latch bits and move them over to the LED bit. So we want LED 1, for instance, to take on the value of latch bits, but we want a particular latch bit. And I think you do that with something like that with a number in there, so maybe that's 0, not quite sure. Is there an example in here of that? There probably is. Down to, yeah, I suppose it could just be the one number, so I think that's correct. And we'll repeat that for the next 3 LEDs. 2, 3, and 4. And we will make this be 1, 2, 3. There's probably somebody watching this telling me I'm doing something wrong, and again, feel free to throw it in the comments. Chip select is what we need to get to, so what did we call that chip select? We called that chip select the N_IO chip select. So we're going to put that down here right before the ROM. There's the basic, there's the interfaces, there's the internal RAM. I think we'll put it right here. And it wants to be equal to 0 when, and then it's pretty much like this line, but a little bit different of an address. So what is that address? That's F, well, let's space it out. We'll take out the spaces. FF, D, and then 0 and 1. So we were going to make it FF. Let's go back to the memory map here and look and see what he has for the memory map. He has the memory map set for We wanted to put it at FFD4. So FFD4, FFD, and 4 would be 10, and we'll make it just that single address. So this is going to be 1 byte at FFD4. So it looks like we've got the chip select working right. Now we don't have to read any data in for this, so we don't have to put it in the order of the things that are here. If it was a read port, it would need to be somewhere in here, so let's just make a comment. Other I/O that is read goes in here. Probably a good place just to make a note while we were there. So let's go ahead and see if this thing compiles. I'm sure there's errors in here all over the place. Save it, yes. And I'll pause the video here and wait and see. Oh, didn't need to pause the video. It looked like it failed pretty quick. What did I miss? NIO chip select is used but not declared. So okay, that's got to be a signal just like the other chip selects probably are up here. Let's go find the other chip selects, which are right here, and make it very similar to the one above it. It's going to be one of these, and it's going to look like space-wise a lot like this. So we'll grab that, put it there, and we'll try to compile again. Usually if you get errors, they come up pretty quick. Let's see what I'm missing now. Got a typo somewhere, it looks like, maybe. Oh yeah, we forgot to take the spaces out. Somebody probably yelled at me when they were watching the video. Oh, you idiot, you forgot to take the spaces out. Yeah, I did. I forget that kind of stuff all the time. Let's try again. We're doing this live, folks, so it's going to be what it's going to be. I'm only so good at this, and the good is not that good. Okay, it looks like it got past the spot that it usually fails in, so I'm going to pause the video here and rejoin it after I've got this uploaded. To do a poke, we need to know the decimal equivalent of the FFD4 value, and I use the calculator that's built into Windows to do that conversion. I select the hex button and then I select the decimal button. So it looks like we need to poke address 65492. One of the things that we have to do that isn't done yet is to assign the I/O pins so that that port is connected up to the LEDs. And to do that, we run the assignment editor, not assignment editor, that's not going to work. We run the pin planner. I click that wrong button quite often. And if we look, we see the LEDs are all assigned to port or pin 74, so that's definitely wrong. And the way to get those pins is to look either at the schematic or some other notes. Let's take a look at the schematic. We saw earlier when we looked at the card that the LEDs are shared with the 7-segment 4-digit display, and so they are on D2 through D5 are on DSDP, DSDG, DSG, DSC, and DSD. So let's go look for those on and find out what pin numbers they're on. Let's use Notepad just to keep track of what pins we're going after. D2 is on DS_DP. D3 is on DS_G. D4 is on DS_C. D5 is on DS_D. Alright, let's go find that in the schematic now. DSDP is on pin 3. DSG is on pin 2. DSC is on pin 1, and DS_D, let's find that. That is on pin 141. So now that we know the pin numbers, we can go ahead and assign them in the pin planner. LED 1 is on pin 3, and scroll through the list till we find it. The next LED, I think these are backwards as I recall. I'm playing with this earlier, but I think it's Going to be good enough for what we're trying to do. It's on pin 2. LED 3 is on pin 1. And LED 4 is on pin 141. I'm going to have to scroll far for that one. So we'll go ahead and close out of the pin planner, and then we'll go ahead and compile it again. Yep, it has been changed. Okay, this is an error we've seen before. Multiple pins assigned to pin 1, and the pins that it has tried to assign are the pin that we did for the LED. It looks like we just have a typo, pins 1 and 2, and we'll go ahead and fix that. I find that sometimes when I'm playing with a scroll bar that I think it scrolls back to a previous value and it doesn't store it like it should. And I see here LED 3 is also wrong. We'll go ahead and store that back to pin 3 again. And I think the way to do it is to click out of the cell, but I'm not really sure. It's a little quirky in my book that I can select it out of the list and then it gets deselected. I'm going to rewatch this video just to make sure I did it right. I'm going to go ahead and add a note here to the decode. 65492 decimal, so that next time I don't have to actually go and look it up. And it looks like it compiled okay, so let's download it and see if it worked. Well, to start with, all the LEDs are lit, which I think is good, because in the schematic, to make the LEDs get lit, you pull them low. And the fact that they're all lit and we put a reset into it would indicate to me that they're working correctly. Let's see where that is. Got to keep changing keyboards because of running to the other keyboard. So yeah, they're pulled low to turn them on, and the reset going into that part will cause them to be cleared. So let's go ahead and see if we can write to them by the poke command and see if that works. Looks like I made a few typos in the switches section. I think this has to have these little arrows to make the assignment. I haven't done that much VHDL recently. I mean, it's been probably 15 years since I've done very much, and I don't have the syntax down completely. I've switched back and forth between Arduino C, C++, Python, and other languages, and I find it kind of hard sometimes to do so many syntax change differences. Looks like we still have a couple of errors here. Thought we were close. Maybe not, huh? Okay, here it's complaining about missing, wrong thing. Need one of these little tick marks instead of a, go ahead and start that compiling, instead of a semi in the middle of the line. Hopefully that'll compile. We'll give it a second here and see if it's getting past. Yeah, it looks like it got past the initial check. Hopefully it's going to work. I find for me that if I do things and make errors, that trains me to do them better. So I don't mind recording my errors here and showing them off to other people, and maybe they type similar errors themselves. I think it's really the way your brain gets trained, or at least my brain gets trained for syntax checking, and it's a good thing to be able to make the errors, have it ingrained into your brain. Oh yeah, I got to put that greater than, less than, whatever symbol in the right place, and that's really how you learn a language, is just doing it, getting syntax errors, fixing them, working your way through logic, just thinking your way through the problems, and eventually you get pretty good at doing this stuff because you just don't like the negative feedback of having to wait for it to compile again. One of the classic solutions for metastability is to put a register before you read it from the processor, and an even better solution usually is to put two registers in series, or two D flip-flops basically, so that it never has a chance of being metastable at the processor side. It might be metastable on the output of the first D flip-flop, but it's usually settled by the time the next clock comes along, and that provides safety to the logic that's after it. It's never undefined, and it's never in some strange state. Okay, that compiled. Let's go ahead and upload it to the card, and then try to read the switches and see what we get. Sometimes it loses track of which blaster it's using. I don't quite understand that, but let's try it again here. Screen cleared, that's good. And it looks like it came up over there. So let's try this with a peak of 65492. And It says error, syntax error, peak 65492 peak. What am I doing wrong? 65492. Did I have a typo in there? I'm going to go need to look and see what's wrong with peaking 65492. For some reason it's coming back and saying syntax error. There might be some check in this that keeps this from happening. I don't think there could be, but we'll try to figure this one out. Well, that's kind of strange because the poke 65492, still works, but peak 65492 doesn't work, and I don't quite understand that. I just tried a peak of 1000 and that didn't work either. It says syntax error. I went online and found a Color Computer Extended Basic manual from back in the day, and wow, this confused looking monitor with the word peak and poke by it sure does fit how I feel at the moment. This might be the answer. An example of peak is A equals peak, and then what is that, the ampersand, I think, H, and then 2115. That might even be a hex number. Looks like a little different format and syntax than what I type, so let's give it a shot again. At the very least, it looks like what I'm missing is the parentheses around the peak. Well, not only do I need the parentheses, but I think I need to print the value that I'm peaking too. That seems to make a difference. One thing I forgot to do is assign the I/O pins, so let's go ahead and do that and see what happens. If you watched our earlier video, you know that the signal naming convention, rather than just having the pin numbers go to the switches, is a little bit convoluted here. So let's go ahead and map these ones again. I think I've done this once before. We've got switch 1, switch 2, switch 3, switch 4, and switch 1 has a U key on it. U key 3. Switch 2 has U key 2 on it. Switch 3 has U key 1 on it. Not sure why these are in this order exactly. And then switch 4 has a reset on it. So I don't think we want to play with switch 4, but I'll keep it here just for grins. It should reset the output register if we press it. So let's leave that alone for the moment. Now let's go find those switches here. U key, and there's those, and they go to resistors, and on the other side of the resistors they go to things that are called keys. So U key 3 goes to key 3, U key 2 goes to key 2, U key 1, U key 1 goes to key 1, and reset goes to key 4. So those correspond poorly to the original switch numbers, and that's why I think we got in trouble on an earlier video. But let's go find out what pins on the FPGA those key values correspond to. I guess we could just type in key 1 and find it. Let's try that. So that gives us the switch, and that, and I'm missing it. Let me go look for it. There it is. I was just looking at the wrong thing. So key 3 is on pin 88. Key 2 is on pin 91. Again, another funky order. Key 1 is on pin 90. And key 4 is on pin 89. So let's go ahead to go to the assignment editor, or the pin editor. Back here to the pin planner, and find the keys. And are they missing? Switches, sorry. Yeah, and they all got assigned to 74, which is what this tool seems to do when it doesn't know what to do with things. I've seen frequently them assign all those pins to pin 74. So let's see, switch 0, we'll just call that 88. 88. Switch 1, and it popped off that. Did it lose the value that I had put in there? Nope, it's still there. Switch 1, We're going to put that on 91. I don't know what I'm doing that's causing it to jump around a little bit. And a little bit quirky at times. And pin 90, the next one. What if I click over there? Nope, it still wants to jump somewhere else. And switch 3 is on 89. And it looks like 89 is going to reset already, so I think we can, I don't know if we can put two things on the same pin or not. Let's try it. No, I think it's probably going to complain. Yeah, because we've got reset on pin 89 already, so we'll just leave it on. I don't know what 74 has on it, but we'll just leave it on there for the moment and see what happens. Go ahead and close that. It looks like they're still all 98 and 99, 98. What am I on? Oh, I'm on the wrong pins here. Okay. 88, 91, 90, and then some other pin here. So I don't know what we're going to do about that one at the moment. We could probably get rid of that out of the list. Maybe we should do that. Let's eliminate it from here. Delete it. And yes, we want to delete it. Yep, we're going to have to update the top level design. Let's go ahead and close out of here. That means we only have 3 switches, but that's probably smart because one of them is reset anyway. So back up to the switches read, there is no switch 3. So we'll make that 0. So we'll be seeing values of 0 through 7 on the switches. I think they're pulled up by default, so if you press them on, it should go low. So that took care of switch 3, and now let's go find switch 3. If it's anywhere else, because I'm sure it is. Yeah, it's there, and it doesn't need to be on an I/O pin any longer. Let's take it off there, see where else it is. Didn't find it anywhere else, so that's good. Looks like we took care of it. Let's see if that compiles. Yep, we want to save it. We do mean it. Let's see if we get past the initial dumb checks here, and yeah, that's about where we know it's going to be okay. That compiled, and one of the annoying things, and boy, I'd like to know how to fix this on Quartus, is that I've got 2 screens running here, and every other time it seems like it puts up the results on the other screen. Wish it would just always stay on this screen, and it does literally seem to be every other time. Not quite sure why that's the case. Maybe that's where I had my focus, and maybe that's why it put it up there, but I kind of wish it would just stay over here. Let's go ahead and upload that and see if it works. Upload it, and we'll try the print peak again and see what that gives us. So print peak, and it was 65,492. Wow, that was interesting. Oh, I put a number at the beginning of the line, so if I do run, it gave me back a 7, which is really exactly what I expect because none of the buttons are pressed. So let's go ahead and run it again. But this time I'll press one of the buttons and we'll see what we get back. I got back a 3. So it looks like it's working. Not sure that's the button I pressed exactly. I pressed the middle button, which I wouldn't have expected to give me that result, or the second button over. But I found these to be backwards at times and not quite as easy to figure out. Let's try pressing a different button. We'll press the center from the left, or the 1 second from the right, and see what happens. And that gave me back 5. So it looks like we've set up code to read the switches, and that's kind of cool. That's kind of what I was looking for. How about writing a little basic program to read the switches and then write the lights and see what we get out of that. That should be a lot of fun. So we created a little program here that reads that peaks the switches and puts it in a value RV, and then it pokes that value out, and then it goes back to 10. So it runs forever. There's nothing stopping it short of pressing a break key. But if I press one of the buttons, I see the light LED light up, and they're in backwards order. So I think the LEDs are right to left incrementing, and the switches are left to right, as I recall. So it looks like they're actually working properly on. When I hit the reset switch, it reset it, which does a cold start, or excuse me, a warm start. And if I run, it's running again, so I should be able to press the buttons again, and the right 3 buttons go through out, and if I press the far left button, that's the reset button, so I don't want to press that. But it looks like we've got I/O running, and it's continually reading and continually writing out what it read. So kind of cool. A little bit of programming. Again, this would have been installing 3 switches on something and putting a buffer to read them, and maybe something to protect that to be metastable, which I haven't done yet, but could easily be done. Anyhow, I think we've exhausted this subject and built some nice I/O demonstration into the card as an embedded function, and I think that's a good, useful thing to do. I think that'll wrap it up for this video. Thanks for watching. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.